Deploying a single AI agent is easy. You tune a prompt, connect a few tools, and it works. But operating a sprawling network of autonomous agents across enterprise workflows is an entirely different, complex engineering challenge. DevOps handles deterministic code, executing instructions step by step. MLOps governs predictive models, recognizing patterns to generate static outputs. But autonomous agents evaluate live context, weigh branching decision paths, and trigger external tools to complete multi-step goals. Because this reasoning is dynamic, failure modes are often non-deterministic. An agent might loop endlessly or drift off script, while the underlying code continues to run perfectly, rendering traditional monitoring tools blind to the error. Managing these systems requires a specialized operational layer. We have to treat agents not as one-time deployments, but as long-running entities that must be provisioned, governed, and eventually retired. Standard DevOps and MLOps pipelines lack the instrumentation to track reasoning chains. Without a dedicated Agentic Ops discipline, these autonomous decisions remain unaudited, leading to failures that are difficult to detect or resolve. Building a reliable practice requires an 8-pillar framework, moving AI governance to a strict runtime enforcement layer. Pillar 1 is design and provisioning. Every agent requires a unique cryptographic identity in a centralized registry, ensuring every tool call is tied to an authenticated source. This identity enables least privilege permission scoping. Restricting an agent to the minimum access required for its specific task prevents overreach and limits the impact of a potential prompt injection. Pillar 2 is workflow orchestration. Enterprise systems rely on networks of specialized agents, collaborating on multi-step tasks. The orchestration layer manages these handoffs, ensuring tasks are correctly decomposed and assigned. This layer also enforces strict output validation. Before one agent's data moves to the next node, the system verifies schema conformance and content safety to prevent errors from cascading through the workflow. Without these first two pillars, an agentic system is merely a collection of uncoordinated prototypes, rather than a production-grade enterprise workflow. Pillar 3 is real-time observability. Instrumenting an agent requires capturing decision traces, the specific inputs received, the options the agent considered, and the reasoning path it chose. We also monitor for semantic drift by comparing current outputs against a validated behavioral baseline. This allows operations teams to replay problematic sessions for root cause analysis. Pillar 4 covers performance and cost management. Ops teams use model routing to balance latency and expense, sending high-volume, simple tasks to smaller models while reserving frontier models for complex reasoning. Sustaining operational SLAs also requires strict context window discipline. Pruning unnecessary conversation history and caching stable knowledge base results prevents runaway token costs and keeps inference efficient. Visibility into the reasoning process, combined with granular control over compute costs, transforms an unpredictable agent into a debuggable, economically viable asset. In regulated environments, Pillar 5, governance and policy enforcement, is mandatory. It moves compliance from a static document into a runtime enforcement layer. We achieve this through policy as code. Access controls and action limits are evaluated automatically at every agent decision, instantly blocking any operation that violates a machine-readable safety policy. Pillar 6 is human-in-the-loop integration. Autonomy does not mean leaving systems unattended. It means building structured paths for human intervention. Tiered escalation routes, actions based on impact and uncertainty. While low-risk tasks process autonomously, any action crossing a high-stakes threshold triggers a request for explicit human authorization. These approval queues provide full decision context, showing the agent's plan and potential consequences, so a human reviewer can make an informed decision in seconds. This combination of automated policy guardrails and streamlined human escalation turns experimental AI risks into auditable operational liabilities. Pillar 7 is continuous learning and drift control. Because operating environments change, an agent's performance must be tracked against its original statistical baseline, triggering an alert the moment its reasoning depth or tool call frequency deviates. These alerts prevent subtle behavioral drift from becoming a system failure. When drift is detected, we update agent instructions through a controlled change management process, rather than relying on ad hoc prompt edits.
This creates a feedback loop where human rejections and drift signals are used as training data to improve the agent's reasoning calibration over time. The final pillar is agent lifecycle management. Managing the end of an agent's active life is as critical as its deployment. We must map all downstream dependencies and explicitly revoke service identities before decommissioning. This prevents orphaned permissions and dangling integrations from becoming security gaps in the infrastructure. Mastering the full lifecycle, from initial provisioning to secure retirement, ensures an enterprise agent network remains resilient as it grows from dozens to hundreds of nodes. Assessing your progress requires the AgentOps maturity model. Level 1 is POC and ad hoc, where individual teams build experiments to prove a use case. Level 1 environments lack shared infrastructure. Permissions are often overscoped, outputs are unaudited, and there is no clear path to production reliability. Level 2 is monitored. Teams track session logs, latency, and error rates per agent, but they remain blind to the semantic drift that leads to silent reasoning failures. The immediate goal for enterprises is Level 3, governed. Here, operations are systematic. Every agent is registered in a centralized catalog, policies are enforced through code, and escalations are handled through structured queues. The ultimate target is Level 4, optimized, where drift triggers automated remediation and inference is continuously tuned for cost efficiency. Organizations must prioritize Level 3 governance now. Once agent populations scale beyond a certain point, manual oversight and ad hoc troubleshooting become impossible.